Uh, Hi guys, yeah, welcome back once again to the brand new session of this process management, like operating system programming concepts. And the topic for today is process management, and it's related with lab number 3. Okay, that we will do in the next session. We'll try to solve the numerical, just the programming numerical, uh, which is related with process management. So before beginning the session, so here I would just like to present you some thought-provoking concepts. And the thought for today is a child. Yeah, it goes like this: like a child on a farm sees a plane fly overhead, right, and dreams of a very far away place. Whereas the pilot on the same plane sees the farmhouse and dream of his homeland. And that's life. So okay, with this thought of today, let's begin our session. So what is the process? As I have already presented all those slides, okay, of operating system concepts in my playlist operating system concepts. Okay, I will strongly recommend you guys to go through all these topics before following this course, because this is mostly related with operating system programming concepts, which is where we just try to solve the programming problems related with a particular topic. And relating with the process, for us, simple description of a process is like it's just an instance of a program. As you guys already know that to solve any problem, we have to do is we have to come up with the algorithm. Okay, algorithm means some certain steps, some procedure to solve the problems. And this algorithm is written in some particular it's coded in a particular syntax. Okay, and it's called a program. So a program is some logical arrangement of this algorithm that you use to solve the problems. And then this program consists, like the instance of a program is makes up a process. Okay, yeah, and you have to understand this program is stored in a memory. So yeah, and all this, anything, okay, that is like a command or a shell script or any binary executable or any application can be quoted as a process. So if you go and check out here, ls, this is a process. ls minus l is a command, but this is a process that printed out the listing of the that is stored in this particular directory lab 3, right? Now, so what are the attributes of the process then? You guys can check out, like you will see like visually you will see by the means of the command, okay, in the terminal, about to see and check out the attributes of the process. But for the theoretical description, we have like 5 kinds of process attributes, and the first one is like PID, and it's just a process ID. Okay, and it's just used by a kernel to identify the process, similar to how the inode number is used for the file identification. And the second important process attributes is a parent process ID, which is related with the PID, the process ID. And a process which creates a process is a parent process, right? as you know that by using the system called fork, we created the process that is a parent process and has a identical copy of a child process, right? So, and the process being created is the child process. So there is a parent process. By using a fork, we create a child process which is the identical copy of parent process, and the child process can get the information of the ID, the process ID of the parent, by using this PPID, by the system called get PPID, right? And this particular ID that we get from that system called is called PPID. Whereas the third attribute is a Terry typewriter, and it's just a terminal in which the process is associated to. And there are some processes, which do not belong to any kind of terminal. They are called daemons. So these daemons are something that which runs in a background. And they are also called as a background process. And for example, while booting your computer, the process that runs in a background, and these are called daemons. And the fourth attribute is a user ID. So it's just the process that to whom the user to whom the processes belong to. So it's the ID that denotes the user to whom the process belongs to. And lastly, it's called the file descriptors. It's just an abstract indicator for accessing a file. So the file descriptors are related to the process, and the process that are related to the file descriptor are input, output, and other file descriptors. So right now, after going through this concept, here we check out how to create the process then by a simple system call that is called fork. And the fork returns 0 to a child process, whereas the PID to parent process, and -1 to the error, in case if any kind of error occurs, right? As I have already told you that the fork system call creates an identical copy of the parent process. That means there are two processes, one is a parent and another is a child process. So this parent process is so which of these process among parent and child they execute first, or the terminates first? And for that situation, it's identical copy. In that sense, it is like they are all executing in a parallel situation. So they both execute or they terminate together. Now here is some particular example that shows you how to create one child process, process, and similarly I have also given an example that creates two child processes. Right? Sorry. So let's go through the process and just check it out. This is the program to create just only one child process. Now let's just execute it. You can check out the situation here. Here, important thing is you have included the Unix standard header file, and with that Unix header file, you can use all the Unix identifiers and all the functions used by the here. So you can also use the system called fork. So parent, my PID is something like this, and my parent is process something, and this is a parent. This is saying that my PID is this, and my parent PID is something like this. Let's just close this. Go through. And then we fork it. If it is the fork returns 0, that means it's a child, and it respectively its standard output, it prints out this statement, whereas in the parent it prints out this particular statement, and lastly it executes, like exits. Okay, so you guys can see these situations, right? Yeah, it's just saying that parent, the statement is printed out, my process ID is this one and my parent process ID is this one, and whereas the ID written by like the parent is something like this, whereas the ID written by the child is this one, because child returns the ID that is 0. Okay, so this was just about single child process creation, whereas here is a two child process creation situation in which, like, okay, let's check it out. Okay, so this is a particular program. So we have like two PIDs, right? PID1 and PID2. Yeah, so respectively you could just also print out the statements and you try to do the for, and you just check out that if PID1 is equals to 0, so then you just say that this is a child. PID1 returning 0 means PID1 is associated with the for, so that means if it is returning 0, that means it's just printing out that the child, what the child returns, that is obviously it will return 0. So else inside the parent we are just trying to fork it second time, that is we are forking second time means we are creating a second child process, right? So if you are creating second child process, you will also check that, you will also surely check that is it a child or not. Yeah, if it for child, creating the second process by using for, you also respectively check if it is 0, it's a child, it returns the particular statement, and else like you also return the parent, like whatever the parent returns, and obviously it will return different from 0, right? And lastly it executes or exits. Yeah, you guys can check out here, like the situation is this one. ID return to child is 0 and ID return to child is 0. That means two childs, they are first child and the second child. You can see ID return to parent, my first child is 6117 per PID. Okay, the PID of this child is 6117, whereas PID of second child is 6118. And similarly we just created two child processes, right? Okay, now there is a second system call that is very important, that is called sleep. And sleep is just to, yeah, we use this sleep system call just to perform sleep, that is sleeping for the assigned time, that is in seconds, right? Yeah, okay, so you have to also understand that whenever this time, whenever you call the system call, okay, for particular case like you call the system call that is sleep, then you requested the time, okay, requested what the sleep system call returns. Then if the time has elapsed, then it is going to return E0. But this system call on the process of delivering the signals, the sleep returns the amount that it has slept minus the amount that actually requested time. Like for example, if you request like 10 seconds, so if you call the system call sleep, then what is going to return in the after 5 seconds? So after 5 seconds it is just going to return you 5, okay, because it will return the unslept amount of time, it will not return 0. So it will Unslept means like the time requested minus the time it has slept. Okay, so with this situation, like, let's go to the second question, and it says that how many ways can a process run then? Most importantly, like, we have two cases of two process, two case or two ways to run the process. That are like background process and the foreground process. I have already discussed you, like, the background processes like daemon, right? So you guys also can create a background processes using the commands. There are some particular commands for creating background processes, but let's go through this. What is a foreground processes? So, like, if you want to see the foreground processes, the usual, if you check out through the terminal, you can see that there are some, like, anything like ls. Okay, this command, the processes, this command, like, process, the command is can also be process, right? So this command is particular process, and the process is running in a foreground, and this is a foreground process. Okay, so and for background process, usually what we have to do is we have to use the ampersand sign, ampersand keyword or something like this. So if you want to create any kind of background processes, you have to just use ampersand. Okay, so it's a background process. Okay, now I have to explain that. Okay, so this is just to use the background process, we have to use ampersand sign. And the advantage of running a background process is like you can run other commands. Okay, we actually do not have to wait until it completes or starts another. We'll check out, okay, in the example in the lab session, okay, where we will try to just solve the programming numericals. Okay. Okay, so there are some particular commands which are very useful for the process management. They are called PS, that is for normal listing of running process. So, okay, let me show you here. PS, normal listing of the process. That is one is the bash. Okay, and you can set process that I just run this command PS, right? PS is the script where we are just running right now. The terminal. So there are some kind of options for which we can use the process commands are like some options are a -a that shows information about all users. Okay, so these are some important commands for all users. Is this one ffmpeg. Okay, but for all use, like I'm using something, this software here, down here. And PS okay, shows information of the process without terminals. Okay, so also there are some additional informations are also shown here. It is like PSU, that is everything is shown here: stat, start, time, command, user, okay, PID, CPU, percent of CPU used, percent of memory used. Okay, so VSJ, okay, RSS, something like this, TTY, the terminal, additional information. So and these are some other extra source information of process without terminals. Okay, these are process without terminal. That means from process that I am running here, all these process, extra processes, extended information. Okay, yes, extended information. So these are some other actions. These are just, I strongly suggest to go you guys to check out the manual of the process, and this will give you the documentation about it. Bit of information about process is given, okay, for you guys to just play with this command. And for the full format listing of running process, you can use this command, that is ps-5f. okay, as I have told you before, that there are the attributes of process. Okay, these are the user id, the process id, this is parent process id, this is the c, this is as time. Okay, terminal, time, and command. Okay, so the 5 important things you have to understand is user id, this process id, parent process id, terminal, and the time and command. Okay, C stands for CPU utilization process. S time stands for process start time, and time stands for CPU time taken by this process. So most importantly, like, there are 5 attributes we have to understand, but before that there are also information that is provided: CPU utilization process start time, okay, time, CPU time taken by the process, and the command that started the process. You can check out here. Okay, lastly, there are some 2 important commands that we have to take note, that is stopping the process. Right, before, if you check out ls, for example, n, right, there was some background process running here. So to stop this, I use a simple keystroke, that was Control C. Look, stop the process, that the background process was running. So it's not stopping the back. There are some, like, it was not the background process, but overall it was like something like I will stop the process, right? So for 2 cases, like for foreground process, there are like Control C is used to stop the process, whereas kill -9 and the particular process id is used to kill the process that are in background process. So I will just go through these commands. We will implement all these commands that we have used here. Okay, recently what we have studied here or talked here, all the commands, all the important commands with the particular example, and the implementation with the broad description is provided in the next programming session, that is a lab 3. Okay, solving programming numericals. We'll do it in next session. So this is it for today, just for this some conceptual idea about process management, and later on we'll just try to solve and use all these commands in a practical way in lab number 3. Okay, so thanks for listening.